Hello physics students, welcome to another edition of Impulse Momentum Connection. Today we are going to be talking, just going through a couple of example problems that you might find on your homework, so if you're struggling with that, check out this video. So we have been talking about the connection between impulse and momentum. We have learned that an impulse, meaning a force over a given amount of time, causes a change in momentum. So an impulse causes a change in momentum, and that was related directly to Newton's second law. So here I have two example problems. We'll go over each one at a time. The first is a moving ball, or a big medicine ball, caught by a person on skates. Well, let's just think about this for a second. If I go ahead and throw a big heavy medicine ball and my friend, Physics Pony throws me a medicine ball and I catch it, what might happen to me if I'm on roller skates? Well, probably I'm going to start to roll back a little bit. Not at the same speed of the medicine ball, but the medicine ball is going to exert a force on me. I will exert a force on the medicine ball. The medicine ball will probably start moving a little bit slower after the fact. And we'll see this. So the first thing I want to do, we're just going to fill in all the blanks. So this states our momentum 1, or our momentum before. So remember the formula for momentum. P equals m times v, right? So we have our mass, 6 kilograms. Our velocity is 6 meters per second. So our momentum is going to be 60 kilograms meters over seconds. All right. So there's our momentum 1. Well, now we need to figure out ultimately our momentum 2 and the final velocity. But we are told that we're given an impulse, or this ball, over the time during this collision, experiences an impulse of 50 Newton seconds. Well, remember in one of the last videos that we talked about Newton second being the same thing as a kilogram meters per second. I'm not going to go into why in this video. Watch the last video for more information on that. But impulse equals our momentum change. Remember, impulse causes a momentum change. Our impulse will be the exact same as our momentum change. So our change in momentum is going to be, and this was to the left, or a negative 50, so that way. And our change in momentum is going to be negative 50 Newton seconds, or negative 50 kilograms meters over seconds. So, if our momentum 1 was 60 and our change in momentum is negative 50, well, our momentum 2 is going to be 50 less, right? And so we're going to have 10 kg meters per second. And so if our total momentum after they catch the ball is 10 kilogram meters per second, we can work backwards to find the velocity. So our momentum equals mv. And I'm going to do it up here just in case you can't see with the table. What I find works the best is to just plug in all the numbers. So 10 kg m over s, that's our momentum, equals our mass. Our mass doesn't change, 10 kg times our velocity. Divide by 10 on both sides, 10 kilograms, and our velocity will equal 1 meter per second. Right, so that's how we work through thinking about this. If you have any questions, reach out to me. More than happy to answer any questions. But we're going to move on to the second example problem. So this one is a tennis ball colliding with a wall and coming to a stop. Normally a tennis ball would bounce off the wall, but I just wanted to go through this part of the problem. These are actually problems right off of your homework. I didn't assign these problems, but they were just extra problems that I figured I would do some examples on. So they're very similar to your homework. So momentum one. This tennis ball is, so just example situation. The tennis ball is stopped, we hit it, and it speeds up, and then it collides into a wall and comes to a stop. And that's where we're going to stop this problem. So if a tennis ball is stopped, remember our formula for momentum is mv. Well, what's our velocity if the object is stopped? It's 0. And so if we have a velocity of 0, our momentum will also be 0. So our momentum here is 0 kilogram meters per second. All right. Now, we're told that we have an applied force of 60 newtons for 0.1 second, 0.15 seconds. So we need to figure out what our impulse and what is our momentum change. Well, the formula for impulse is force multiplied by time. So we just take our force, we multiply it by our time. 60 times 0.15, we have 9. So our impulse is 9 Newton seconds. Remember, that's the same thing as kilogram meters per second. And in the last example, we talked that our impulse equals our momentum change. So this is going to be also 9 Newton seconds, or kilogram meters per second. So now this ball is moving. We applied an impulse, it is now moving, and we apply the impulse to change the object's momentum, so the new momentum is going to change by this much. Well, how much did it change by? It changed by 9. It started at 0, it gained 9, and so our new momentum is 9 kg m over s. And I know it's probably a little bit weird switching between Newton seconds and kgms, but just know they're the same thing. All right. So now we come and this ball hits the wall and comes to a stop. Well, what's going to be our final momentum? It's going to be 0 because the ball is now stopped again. So 0 kilograms meters per second. And our change in momentum is going to be negative 9 kg m over s, right? And remember, momentum change equals impulse change, or impulse, so minus 9 kg m over s, or Newton seconds. All right, and now we want to figure out the force on the wall. So I'm going to write it up here. Our force multiplied by time equals our impulse. And let's just, our impulse was negative 9, so minus 9 equals our force, which we don't know, multiplied by time, which is 0.05. So now we want to figure out what our force was. We divide by 0.05 on both sides, and force equals 180 newtons. So our force is 180. Hopefully this was helpful walking through a couple of these example problems. A couple of key takeaways. These momentums are just snapshots at different times. impulse, and impulse causes a change in momentum, and so it's going to change the momentum from this picture to this picture, so that's why these are all in the middle, that this changes this object's momentum from here to here. These will always be the same. They're always going to be the same. And if you get mixed up multiplying, dividing, I really encourage you to write out the formula. It's just one extra little step, but it really helps students just make sure they're plugging in the right numbers in the right places. Just take that extra little time and it will help you greatly. Again, thanks for watching, and we'll see you next time. Bye-bye.